Hello, this is Tam Vu, and I am about to demo to you Lab 4 of Elec327. The whole point of this lab is to create a Simon game where an LED would flash a random number between 1 and 4, and then we would match that number by pressing the same amount of times on a button. If we fail, we will get game over. Alright, so let's get started. First with the code. First, I declare the function on top, function random int, which will return a random number between 1 and 4, and then I also initialize a bunch of variables that will be useful later when implementing the game. In my main function, I initializes all the states so that I can play the game properly. You will notice that I use both timer A0 and timer A1. The main point of timer A0 is so I could call the interrupt function for timer A0 that will control the game, the main part of the game. Timer A1 is used with a different frequency from timer A0 so that I could use the counter on timer A1 as a random number generator that will be useful for calling the function random int. Basically, the point of all this initialization is I declare pin 1.3 as the input pin for pressing the button, and pin 1.0 as the output pin for displaying an output to the LED. I set CCR0 to 5000, which will give the player a reasonable amount of time to press the button, so that the interrupt vector for timer A0 will not be called way too fast. I also enable interrupt and enter low power mode 0 to conserve some energy, and of course I also enable interrupt. In my random int function, I determine what number between 1 and 4 to return by offsetting the counter from timer A1 with a random offset that will be determined by the value of timer A0. And I also AND that with hex 3, which will save only the last 2 bit. So all that will give a number between 0 and 3. That's why at the end I add a +1. So the whole function will return a number between 1 and 4. In my timer 0 A0 interrupt vector is where the main game is. It starts out with the game state being equal to 0, which is the intro game state. It will flash the intro sequence, which is just a periodic one flash. When the player presses a button to show that he or she is ready to play the game, it will enter game state 1, where it generates a random number between 1 and 4, and then flash that many times with the LED. Each flash will be at a rate of about 1 Hz, and after it finishes flashing that, it will enter wait mode. During wait mode, it will increment the timer every time the interrupt vector is called, but it will not do anything else. During the wait mode, if the player presses the button, it will increment the variable press, which will keep count of how many times the player has pressed the button since wait mode has started. After the timer goes to above 5, which means the interrupt vector has been looped for more than 5 times, it will check to see whether or not the number of times the button has been pressed is equal to the random number that was generated. If it's not, the game state goes to 2, which is game over. In game over mode, it it repeatedly flashes a series of 3 quick flashes to show that the game is over, and it will repeatedly do that until the player presses a button to show that he wants to get out of game over mode. When the player presses the button, it will return to game state 1, which is the main game state where the player can play again. And at the end, you can see that every time the timer A0 interrupt vector is called, the timer count will increase by 1 to show that time is passing while the player is playing the game. Finally, we have the button interrupt vector. First, whenever the button is pressed, it will reset the interrupt flag so that the interrupt vector will not be recalled again for only one press of a button. Then it will increment the press counter to keep track of how many times the button has been pressed. Then the last thing we do is to save the current value of timer A0 in the counter register, and that random number that we save will be useful later in the random int generator. For the circuit itself, first we have the red and the blue wire that is powering the voltage supply and the ground to the whole circuit. Then we have the yellow and green wire, which is connected to test and reset for the MSP430. The button is connected to pin 1.3 and the LED is connected to pin 1.0. I implemented debouncing using a hardware capacitor by putting the LED in parallel with a capacitor and a resistor. So the patch from pin 1.3 could either go through the LED to ground or go through a capacitor and a resistor to ground. This will cause some stored energy when the LED is pressed, so that instead of it oscillating between 1 and 0, it will slowly go from 1 to 0 for the voltage on pin 1.3. See how this game works. The LED is currently flashing the intro sequence, which is just a series of flashes. When I press the button to show that I am ready to play the game, it will flash a random number of times between 1 and 4, and I have to correspond to that with an equal amount of presses on the button. If I get it right, it will keep on going until I get it wrong. So now, let's demonstrate that. Now watch what happens if I do not press anything. When I ran out of time before I could press the correct number amount, it will enter into game over state where it flashes very crazily until I decided that I want to replay the game by pressing this number. Now when I press this button, it will go back to the main game state where it will flash a random number between 1 and 4, and then I would have to press the same number of times on the button. Now, this time around, let's see what happens if I press too many times instead of not enough time. So let's play the game. So let's see what happens if I press too many times. 1, 2, 3, 4, 5. If it detects that I press too many times, it will also enter game over state.